In the constellation Orion lies a star that has intrigued astronomers for centuries, Betelgeuse, a red giant that has inspired both wonder and scientific curiosity among countless sky watchers. Unlike many other stars, Betelgeuse is easily visible to the naked eye, shining brightly as one of the most distinctive points of light in the night sky. Its massive size alone is awe-inspiring. Betelgeuse is far larger and much more massive than our Sun, making it a cosmic giant in every sense. This imposing presence in the cosmos has earned it a place of honor and fascination among stargazers throughout history. Recently, however, Betelgeuse has exhibited strange and unusual behavior that has raised even more interest, along with a touch of concern among astronomers. In recent years, this once reliably brilliant star has begun to dim significantly, and scientists have detected violent vibrations emanating from within its core. These unexpected changes have left astronomers puzzled, sparking intense speculation and discussion in the scientific community. Many scientists now believe that Betelgeuse could be nearing the end of its life and might be on the verge of a spectacular and catastrophic supernova explosion. Such an event would signify the culmination of the star's existence, a dramatic cosmic finale that would be visible from Earth and would have far-reaching effects on the surrounding region of space. However, some wonder if there might be something even more mysterious and potentially terrifying occurring within this red giant. What if, rather than exploding outward as expected, Betelgeuse were on the verge of collapsing inward, creating a cosmic event that defies current scientific expectations? Join us as we embark on an exploration of this stellar phenomenon, venturing to Orion's shoulder, where Betelgeuse resides, to investigate the ongoing changes within this massive star and the possible implications for Earth. Betelgeuse is far from an ordinary star. It is a red giant of truly colossal proportions, dwarfing our Sun in both size and mass. To understand the scale, Betelgeuse is estimated to be roughly 1,000 times larger than the Sun, placing it among the largest stars ever observed by humans. This astounding size makes Betelgeuse an object of unending fascination, as it stretches our understanding of the physical limits of stars. Yet beyond its incredible dimensions, Betelgeuse has another striking feature: it is nearing the end of its life cycle. Unlike smaller stars like our Sun, which have relatively stable, long lifespans, massive stars such as Betelgeuse burn through their nuclear fuel at a much faster rate. This rapid consumption of fuel means they experience shorter, but more volatile life cycles, ultimately leading to their inevitable collapse. For Betelgeuse, this translates into a sense of urgency, as it could collapse and explode in a supernova at any moment. This impending end has earned Betelgeuse the moniker of a ticking cosmic time bomb. Despite being approximately 650 light-years away from Earth, Betelgeuse exerts a profound presence in the astronomical community. Its brightness has captivated stargazers for centuries, making it a radiant beacon in the night sky. The true scale of its energy output, however, is even more extraordinary than its visible light. Only about 13% of Betelgeuse's radiant energy reaches our eyes as visible light, but even this fraction is enough to outshine most other stars in the sky. If we could somehow observe the star's full energy output, Betelgeuse would eclipse Sirius, the brightest star in our sky, by a staggering margin. This idea alone hints at the immense power Betelgeuse holds, a cosmic force that both awes and humbles us. Consider the unimaginable scale of Betelgeuse. If it were placed where our Sun currently resides, its radius would stretch far beyond the limits of our solar system. Its outer edges would extend past the asteroid belt, nearly reaching Jupiter's orbit. In this scenario, the inner planets Mercury, Venus, Earth, and Mars would be entirely engulfed and consumed by Betelgeuse's outer layers. The sheer magnitude of this red giant boggles the mind, drawing us ever deeper into its cosmic allure. Yet, the mysteries surrounding Betelgeuse do not end with its size and mass. Every 1,000 years or so, Betelgeuse sheds a significant portion of its outer layers, creating a remarkable stellar spectacle. The star ejects material into space, forming a massive nebula, a cloud of gas and dust that surrounds Betelgeuse like a cosmic halo. This nebula is an astonishing 250 times larger than Betelgeuse itself, extending out to nearly 30 astronomical units, which is the distance between the Earth and the Sun. This nebula not only highlights the immense scale of Betelgeuse but also invites us to witness a kind of cosmic dance as the star continuously sheds its outer layers, revealing its inner secrets in a grand display of stellar evolution. At the heart of Betelgeuse lies a fiery and powerful process, nuclear fusion, where hydrogen atoms are fused together to form helium, releasing vast amounts of energy. This fusion process powers the star, radiating energy that spans across the cosmos. However, as with all massive stars, Betelgeuse will eventually deplete its supply of hydrogen, prompting a dramatic transformation. When the hydrogen is exhausted, Betelgeuse will shift to fusing carbon, a process that generates an intensely brilliant glow visible across vast distances. However, even this stage of fusion is not sustainable in the long run. Eventually, Betelgeuse will reach a critical point when it begins to produce iron through fusion. Iron is a unique element in the life cycle of stars, as it cannot release energy through fusion. As a result, when the core of Betelgeuse becomes dominated by iron, it will no longer be able to sustain the massive weight of its outer layers. Without energy to counterbalance the crushing force of gravity, the star's core will undergo a rapid and violent collapse. This collapse is the precursor to one of the most dramatic events in the universe, a supernova. If Betelgeuse indeed reaches this point, the resulting explosion would send shockwaves across the galaxy, scattering elements and energy into space. This supernova could be visible from Earth, appearing as a bright new light in the sky, perhaps even visible during daylight hours. The fate of Betelgeuse offers a fascinating glimpse into the life cycles of massive stars and serves as a reminder of the vast cosmic forces that shape our universe. As scientists continue to monitor Betelgeuse's behavior, they hope to learn more about the mysterious processes occurring within this red giant. The story of Betelgeuse is, in many ways, a story about our own cosmic origins, as the elements forged in such stellar explosions eventually contribute to the formation of new stars, planets, and potentially even life itself. The study of Betelgeuse thus carries profound implications, as it not only deepens our understanding of stellar evolution but also connects us to the broader narrative of the cosmos, reminding us of our place in this vast interconnected universe. In the universe, a supernova explosion of Betelgeuse will release a force so powerful that it will equate to the energy of 10 billion suns, a cosmic shockwave that will reverberate throughout the galaxy. Stars like Betelgeuse undergo fascinating transformations during their lifetimes, changing in color and brightness as they age. In their early stages, stars often appear bright blue, a sign of intense heat and youthful energy. As they age, they cool down and take on the red hue we now associate with Betelgeuse. This change in color has been observed for millennia, as far back as the 2nd century BC. Chinese astronomers noted Betelgeuse's distinctive red color, observing how it stood out among other stars. This observation was echoed by Ptolemy, the renowned Greco-Roman astronomer, who in the 2nd century AD described Betelgeuse as having a reddish or orange hue. The consistent coloration of Betelgeuse across different cultures and centuries adds to its allure and mystery. Even medieval Middle Eastern astronomers were captivated by Betelgeuse, and its appearance in historical records highlights its prominence in the night sky. This long history of observation underscores the enduring significance of Betelgeuse in both science and culture. In 2019, Betelgeuse surprised the scientific community by suddenly dimming in brightness, a dramatic and unexpected change as the star's light output dropped by nearly 50%, puzzling astronomers who had long studied its behavior. Initially, some scientists theorized that the dimming was caused by a large cloud of dust ejected from the star's surface, which obscured our view of Betelgeuse. However, this explanation remains debated, and no clear consensus has been reached on the cause of this sudden dimming. Some researchers speculate that a massive planet or other celestial body may have disturbed the star's surface or even been absorbed by Betelgeuse. Adding to the intrigue, Betelgeuse's brightness began to increase again in the months following the dimming, rising nearly 50%, an unexpected reversal, as stars typically grow dimmer as they age. This sudden fluctuation has left scientists searching for an explanation for Betelgeuse's erratic behavior. Stars can change in brightness for various reasons. Some, like the star Mira, go through regular cycles of expansion and contraction, affecting their light emission. Mira, often called the Wonder Star, is known for its periodic changes in brightness, and other stars, such as Algol, also display these cyclical patterns. However, Betelgeuse's recent behavior seems to defy these established patterns. Deep within Betelgeuse's core, a seismic shift was occurring. The star was ejecting massive amounts of material into space, forming a colossal dust cloud that obscured a significant portion of its light. This dust cloud was so vast it effectively dimmed Betelgeuse, lowering its visibility from one of the 10 brightest stars in the sky to a much lower rank. The dramatic drop in brightness shocked astronomers around the world. Betelgeuse continued to surprise scientists with its extraordinary behavior in the months that followed. Theories abound as to what might be causing these dramatic fluctuations. Some researchers suggest that large sunspots or additional dust clouds could be responsible, while others propose that Betelgeuse might be going through coincident cycles of brightening and dimming. Among the most fascinating possibilities is that a supernova explosion has already occurred, but we are yet to witness it due to the vast distance across space for the light to reach us. Some scientists even speculate that the supernova might have happened centuries ago, akin to Kepler's supernova, which illuminated the night sky in the 17th century.